Hi everyone and welcome to Virtual Science channel. We are starting today with our data science series and we are going to learn how to install Anaconda Python distribution and we'll make our first Matplotlib graph. So Python is the mostly used programming language in the scientific community because of its simplicity, very clear syntax, and of course because of very powerful open source scientific libraries. So this series aims for people who are not familiar with Python or any other programming language. And first couple of videos will cover the basics of Python and its libraries, so which are relevant for the data analysis like SciPy, NumPy, Pandas, and so on. So the first step today will be to install Anaconda distribution, and to do so we should go to Anaconda webpage. So we can start by simply typing Anaconda Python in Google, and the first result which appears is what we are looking for, so anaconda.com. And here we are. So as we can read here, Anaconda distribution is the world's most popular Python R data science platform. It's free and it contains a lot of libraries which are relevant for data analysis. And if we scroll a bit down, we can find the installation files. So depending on your operating system, you can choose the appropriate files. I'm using Linux, but if you're on Windows, you can simply click on the Windows icon and then you can choose between two Python versions. So Python 2.7 is the old version, so and you should not use it except if you have a very good reason to do so. So we'll stick to the newest Python 3.7 version, and we can download it simply by clicking on the green button. A bit down, we have a documentation. Where clicking on the blue button, we can find the installation guidelines. For example, if you are installing Anaconda on Windows, you can find all the steps which are required for this installation here. And it's quite simple, and you should not have any problems with that. Since I already have Anaconda installed, I will go to Anaconda immediately. And here we are. So this is how Anaconda Navigator looks like the first time you open it. And what we are going to talk about today is the Jupyter Notebook. In order to launch it, of course, we should just click on the button. And it will open now in the web browser. So if you're using Mozilla or Google Chrome or whatever, it will open there in the web browser. And here you will see some files and folders. And these are files and folders in your working directory. In my case, this is the home folder. So all the folders and files which are present here are also there in the Jupyter Notebook. I will make a new folder here. Let's name it tutorial number 1. And when we go back to Jupyter, we'll see it here in the list. So that's the one way. The other way would be to go to the right corner, click on the new button and then folder. And then a new folder named untitled folder will appear. If you want to rename it, we have to select the folder and then click on the rename button, and let's name it tutorial 2. So okay, I don't need them both, so I can delete the second one. So select it and then delete. Okay, then I will go to my folder tutorial number 1, and because we've just created it, there is nothing inside, so we can start a new project. Going again to the right corner, click on the new, and then Python 3 notebook. So you will see that this file will appear here immediately. Of course, if you go back to the folder, you will see it also here. And default name is of course untitled points and then Jupyter Notebook extension. We can rename the file. If you go back, click on the untitled name and then let's call it my first graph and say rename. So Jupyter Notebook is the way to interactively communicate with your code. So in this video we are not going to talk about Jupyter and its options, or we are not going to talk about Python itself. I will only show you a couple of short examples of how this Jupyter Notebook looks like and what it can do. So let's say that we want to some two numbers, so let's say x equals 6 and y equals 3, and then we want to sum these two numbers, and then we can say run, and we'll get the result as an output. Oops, sorry, here should be y, but we'll get the same result. Okay. Let's make a graph. So I have to import the Matplotlib function from Python, like this, Matplotlib pyplot as plt. I will explain these lines in some of the next videos. This is just an example. So let's make some data. Let's say that we have x, which consists of 1, 2, 3, 4, and 5, and we have y, which consists of 2, 4, 6, 8, and 10, for example. And let's say that we want to plot this, so we say plt plot, and we say what we want to plot, x and y, and then we can say run this. Oops, once again, and here our graph appears. So what we can do else, we can add new epsilon data, so let's say 3, 5, 7, 9, 11, and then plot this together with the previous one. And of course we have two lines, epsilon, y, sorry, and y2. And if we want to change the color, for example, we can do it here. So let's say that we want the color to be red, of course, color of the line, and the second to be green, let's say. So like this, and we want to add the x and y labels. So let's say plt x label is distance, and epsilon label, y label should be time, for example, and run this, and we'll get the x and y labels. So if we want to change the size of these letters, so we can change font size for, let's say, 16 here and there. So like this. And what we can do more, we can add title to this graph. So let's say plt title. Let's say my first plot. And so I will just add one more line. Let's show. And here we are. So this is how we make the graph using the Jupyter Notebook, of course the Python and its libraries. And in the next videos we'll talk more about the Jupyter Notebook, we'll talk more about Matplotlib, more about Python, and I hope that at the end of this series you'll be able to make the very nice plots by yourself. So see you next time, and if you have any suggestions or comments, please leave it in the comment section below, and see you soon. Ciao!